Good afternoon, everyone. This is the pre-launch news conference for CRS-10 to be launched Saturday morning to the International Space Station aboard a SpaceX Falcon 9 rocket. And here to give us a status and talk about the upcoming mission is Dan Hartman, the Deputy Manager for the International Space Station Program at the Johnson Space Center. Jessica Jensen, the Director for the Dragon Mission Management Team at SpaceX. And Tara Rutley, Associate Scientist for the International Space Station Program, also from the Johnson Space Center in Houston. We'll start first with comments from our participants, then we'll take questions here in the audience, then we'll take questions on the phone, and then finally also questions on using social media simply by going to #AskNASA. So we'll start with Dan Hartman, Deputy Manager for the ISS program at JSC. Dan?
Good afternoon. It's great to be here as we close in for the launch of the SpaceX CRS-10 mission tomorrow morning to the International Space Station. We've loaded the Dragon full of supplies, both inside and outside in the trunk. I think we're on the order of 5,500 pounds and the most external cargo mass that we've ever launched in the trunk. And so we're ready to go, and everything looks very, very healthy for us. With launch tomorrow, Tomas will grapple Dragon around 9 a.m. on Monday. That's Eastern time. And then once he grapples, the ground controllers will maneuver Dragon onto the Node 2 nadir berthing port. And so that'll be done by our ground teams. They are doing final training on that over the weekend, and so they'll be ready to go when Dragon does arrive. Our backup launch date will be on the 19th, and subsequently the berthing would be delayed one day as well. We'll get to work immediately on board. The crew will be unloading Dragon and conducting the research that we brought up. On day 2 is when we start all of our external trunk operations, and those run for about 15, 16 straight days. This is the first mission where we're bringing 3 payloads up, SAGE, the SAGE instrument plus its platform, and then the STPH-5 payload. And this will be the first time we end up returning for disposal 3 payloads that have had their useful life on board space station. So we'll be re-entering those into the trunk and bringing those home. And that's a great feature that we can keep cycling out our research over time as the station continues on. The mission duration right now is planned for 29 days, and that would give a return on March 21st. If we looked ahead a little bit, we do have some other traffic in and around the space station coming up. The Progress 66P will launch from Baikonur on February 22nd. That'll be a 34-orbit rendezvous, and with docking on February 24th. So you can see if we tend to slide a little bit with the SpaceX mission due to weather or other issues, we'll have to work with our Russian colleagues on when we can bring Dragon in. Also, the Orbital 7 mission is progressing well. It's planned for a launch on March 19th. I understand Cygnus and its service module were mated here in the SSBF just this week, so that mission's looking great for us as well. And then I'll say post the OA7 berthing operation, which again was on March 19th, and then until Shane returns home on April 10th, we're looking to conduct up to 3 EVAs to knock out some tasks that we've had on our plate for a while. 2 of those will be associated with some MDMs, upgrading some MDMs that we have external that we're looking for better performance. We also need to move the PMA-3, which we're trying to do and get it situated on our Node 2 Zenith port, which then we could bring up our second IDA and have that ready to go for our commercial crew friends for a second docking port. And then there's some other tasks we're going to be changing out, and during these EVAs, we need to be lubricating the Dexter, the SPDM, some of its mechanisms over time. They need a little bit of lube. And then we have a new power converter box that we'll be bringing up and installing for our payload experiments. So we got a very busy time between now and April 10th, and everything per plan. We think we can make it all work. With that, then our new crew would, when Shane coming home on 410, our new crew to the station would would launch on 4/20, and then it'd be a typical rendezvous pattern. Consumable-wise, we're in great shape. We've got well above our reserve levels for food and water, so we've really dedicated this Dragon mission to the research, and it's chock full, and the crew's really going to enjoy the science we're getting ready to bring up. We look forward to an awesome launch tomorrow, and understand all of our late load payloads are in. They're looking great. They're healthy. They're powered on, and the ISS is ready to receive Dragon, so we're ready to go.
All right. Thank you, Dan. And now to Jessica Jensen, the Director for Dragon Mission Management at SpaceX. Jessica?
Thanks, George. Hello, everyone. So first, I want to say that we are proud and extremely honored to be launching off the historic, Apollo and Shuttle launch pad at 39A. This is going to become the primary pad for all of the Dragon missions to the International Space Station from SpaceX. We're going to be sending our next generation of astronauts through the Commercial Crew Program off of this very launch pad, and it feels great. So yeah, we'll be sending them, from American soil on American rockets, and it's awesome. It's very humbling to walk out to the pad and see Falcon 9 standing up next to the 39A tower. It's a sight to see. So it's been great. I want to give a special thanks to the SpaceX team that has put a ton of hard work into transforming this pad. We had to make a lot of infrastructure upgrades and ground system upgrades to make this a modern day pad. We wanted to do that while also preserving its heritage. And so special thanks to the SpaceX team that's pulled all this together. As for readiness tomorrow, Dan mentioned some of this. We had a successful Falcon 9 static fire on Sunday. Falcon and Dragon are currently at the pad. Like Dan mentioned, all of the late load cargo is now in. We load about 1,000 pounds of cargo. So all the time-critical science payloads get loaded 24 hours before launch. It's a unique capability that Dragon has, and all of that should be wrapping up now. Let's see. I think the last bit, yes, we ran all of our final checks this week. We do have one issue that we're working through. We had a minor leak issue. We are still in the investigation for that, so it's a watch item for tonight. But as of now, we are still on track for launch tomorrow morning and with a backup attempt on Sunday. So the way the mission profile is going to work, it's our standard CRS mission to the space station. So what's going to happen is the first stage is going to burn for about 2.5 minutes, and then we get into stage separation. At that point, the first stage will break away, and it flips around. It does the boost back burn. It will then perform an entry burn and a landing burn to come all the way back to Cape Canaveral and land at landing zone 1. The landing is estimated to be about 8 minutes after liftoff. Now, meanwhile, while all that's going on, second stage will still be carrying Dragon to the space station. And the second stage burn goes till about T plus 9 minutes, at which point the second stage engine is going to cut off, and then Dragon gets deployed around T plus 10 minutes. At that point in time, Dragon is deployed, and then we're in orbit, and we start doing all our on-orbit checkouts and activations, including deploying the solar arrays at about 11 minutes into flight. And then at that point in time, we're set, and we begin our two-day journey to the space station. Let's see. So I just want to thank the FAA and the 45th Space Wing. They've been a huge help to us in getting this pad going and ensuring that we meet all the safety protocol and we're doing everything we should, which is great. So their support leading up to this launch and the support that they're going to provide on launch day has been great. So thank you to the 45th Space Wing and the FAA. I also want to thank NASA. NASA's been our partner for over 10 years, and it's been wonderful to work with you guys on COTS and CRS missions. So yeah, thank you for the continued opportunity for us to supply the space station. That's about it for me. We're super excited for launch tomorrow.
All right, thank you, Jessica. And now to Tara Rutley, the Associate Scientist for the International Space Station Program. Tara.
So thanks, everybody. I'm not kidding when I say it's really exciting to be here. I've got to walk around a little bit today on site and talk to some of the scientists who are here processing their payloads that are now fully loaded on the vehicle, and they are amazing. They bring the science to life. You may read about it, you may hear about it from me, but talking to these scientists, their hearts are in it. And it's not just scientists that are here, but there are also students that are here. And it's good to see everything abuzz over in the payload processing facility and everything that's going on outside these doors. So this is really the golden age for space science research. It's a good time to be in the program. We're excited because we have a laboratory that is at any given time going to perform about 300 investigations. Actually, that's just in the next 6 months. And that's what this SpaceX launch is going to enable. In fact, it's going to send research and hardware to station that's going to represent the work of about 800 scientists around the world. And that'll all be performed by the 6 people on orbit. And those 6 people are the proxy scientists in that laboratory where, microgravity is the one unique resource up there that you just can't replicate here on Earth. So we're busy doing things there. We're busy on the ground supporting what's happening on orbit. We are excited because SpaceX also offers the capability to return our samples to our researchers. So anytime we can get those back and get those in the lab, it's a researcher's dream. But I'll tell you a little bit about some of the investigations at a very high level that's being enabled by this particular launch. From the National Laboratory portfolio of research, there are a lot of commercial payloads that go around. They include growing crystals from what's called monoclonal antibodies to help fight diseases. They include stem cell research that could help battle illnesses and diseases here on Earth. Wound healing from the DoD research, which will be happening on orbit. We'll see a company called NanoBioSim that's going to study bacterial behavior in space in ways that could elucidate some of the reasons for antibiotic resistance in some of these superbugs we see here on Earth. And we also have some student experiments in Space Tango's Tango Lab system and also NanoRacks hardware system. And we even have commercial CubeSats that will be sent up on this flight that will later be deployed from Space Station. So exciting newcomers to space station research. But as Dan mentioned, we have a big presence in the external payload facility and the trunk of Dragon that's going up, a lot of hardware going up. A couple of those are Earth observation instruments, and one in particular is NASA's from the Science Mission Directorate, and that's called the SAGE-3 investigation. And its job is to attach to the outside of space station and look for ozone effects and aerosols that affect the ozone conditions of Earth. That's an exciting one because those kind of SAGE experiments have been ongoing actually since 1979, just never before on the International Space Station, where they'll get a really unique vantage point and a global, more of a global measurement capability. So that group is really excited. We also have another Earth observation platform from the DoD called the Lightning Imaging System, and that's LIS for short. And it's going to study the pattern of behaviors of lightning around the planet because it's going to help us learn more about future weather forecasting, things like climate change. We'll learn more about atmospheric chemistry and even be able to detect aircraft safety. These scientists said this morning that you get about 45 lightning strikes per second around the globe, and this particular team has a history of studying lightning in the rainforest areas. Now they'll get a chance to study globally lightning effects too. So we're looking forward to some of the results that come from that. The DoD, I've mentioned before, they have plenty of investigations through their Space Test Program, or STPH-5 if you look it up. They have almost 15 different investigations, and they're part of what's going up in the trunk of the Dragon. And one of them is the LIS program. Another one is called Raven, which is going to be a new system that's designed to basically try to test new navigation systems for autopilot when you're trying to service something like a satellite that wasn't meant for servicing in space. So trying to capture satellites, refuel them perhaps, or repair them, and it's a brand new system. There's also a whole lot of physical sciences going on, and in particular, we have a suite of metal alloy processing studies from our counterparts, our partners at the European Space Agency. So, using the microgravity environment to create solidification of these alloys, looking closely at the changes that occur inside the materials. They are able to get those samples home and perhaps look at new ways to make new materials out of what they find. So you can see that this particular SpaceX launch is going to keep our crew busy. It keeps us busy every day. I love being involved in this because, again, if you have any interest at all in space science or space technology, or even if you're just a curious human being, this is the time. And we've never seen such a platform like this enabled on orbit for science. And so we're making the most use of it, both for human exploration, so we can go beyond low Earth orbit, but also to bring those benefits back to us here on Earth. We want to look at fighting disease, osteoporosis, improve immunity. And so it's really exciting to be here and do that and maximize the benefits that we get from ISS. That's it.
Thank you, Tara. And before we take questions, a few words about our weather forecast coming up for tomorrow morning. There is an upper-level trough of low pressure that's heading our direction, and it's going to bring some increasing cloudiness and some showers to the Cape Canaveral vicinity. But most of what's of concern is not going to be in the area until after launch time. So at liftoff, going to our first chart, the temperature will be near 7 degrees with a relative humidity of 64%. And the winds from the south 10 to 15 miles per hour with a visibility of 7 miles or greater. There is a 30% chance of not meeting the weather criteria because of possible flight through a thick cloud layer. And should we postpone for 24 hours for any reason, look at the forecast for Sunday at launch time. There'll just be some scattered clouds, a temperature near 67 degrees, northwest winds 12 to 17 miles per hour, and a chance of an isolated rain shower. There will continue to be a 30% chance of not meeting the launch weather criteria on Sunday due to possible flight through precipitation or restricted clouds. So overall, a fairly good forecast and no change from our forecast this morning. So we'll take questions now. Please give your name and affiliation when the microphone comes to you, and we'll start right here in the front with Marcia.
Marcia Dunn, Associated Press for Dan. Shane has got his mission a little longer now, and I'm wondering how much more could you bump it if the Soyuz problems continue to persist? Is Peggy's homecoming still on track? And looking ahead, are you looking to pick up some more Soyuz seats?
Okay. So right now, Peggy's on her normal plan to come home when she was scheduled. I will say we are having some discussions with the Russians on, is there an opportunity to, maybe not Peggy, but I'll say a USOS crew member to come home on a later Soyuz. As you know, the Russians will be flying 2 crew on their next mission. And so there might be an opportunity where we can do that. Those discussions are just starting. And so we do see that as a potential opportunity to really enhance the research that Tara was talking about. As far as the Soyuz seats, with buying us, that we have the option or the discussion ongoing with Boeing, and that was a seat in fall of 17, a seat in I believe the fall of 18, and then an option if we wanted to exercise it for seats in 19, 3 seats in 19. Those discussions are still ongoing. Nothing has been finalized yet. I think we're making ground, but again, part of the rationale for going up to a crew of 4 in the 17, at least on the USOS side, we know we're going to be there eventually. It'll help us push our systems, our ecosystem, to see if there's anything out there, lessons learned wise, that we would need to know ahead of time, as well as we can keep the throughput. I mean, it's basically doubling the throughput on the research side, and so that is very, very attractive to us. And so on both fronts, we're looking to hopefully be able to pull those off. As far as Shane's return, I don't know of any threats against the 420 launch date right now. Obviously, we'll get the progress off the ground. We'll have a lot of further discussions with the Russians on how well those stages performed. But right now, we see 420 as a launch date.
Sounds like your French astronaut may be spending longer up there. Is that what you're alluding to? And how much longer would you anticipate keeping someone up there if necessary, or could he be there for a year? I mean, is that part of your talks?
I think there's, again, we have not made any determinations yet. We don't not have any agreements yet with the Russians, right? So we're postulating kind of thing, seeing the opportunity there with that seat open, I'll say. So whenever the 50S vehicle would return would be when that if the deal was made, when that returning crew member would come home, when 50S would return, which is a launch on 420.
Bill?
Bill Hart with CBS. Two questions. One, Dan, just to follow up Marcia's question. Is there any chance at all Nowitzki and Pesquet come home, just the two of them come home in June, and Peggy perhaps stays up in space? Or are you saying that's not a possibility now? I
No,
thought
that was the scenario I was trying to
that's what you're
articulate.
talking about. I
That's
wanna make sure we're
absolutely,
on the
that we
same
would
page.
try to keep one additional crew member up there. That's what we're in the discussions with.
So that's still a possibility at this point?
Yes, it is.
Okay, thanks. And Jessica, can you give us a little more update on what the leak, what the system is that's leaking? All we heard at the pad was helium in the spin system, and I don't even know what that is.
So yeah, it's on the second stage. It is the helium system on the second stage. It is our spin system that is partly used to spin up the turbo pumps. However, it is a redundant system. And so that's about all I can say right now. Yeah, we're into an investigation into it. We're checking it out, and we'll know more tonight.
But that is the same helium system that pressurizes the tank, or is that a different system entirely? In other words, the tank that had your problem in September, is this a separate system, or is it fed from the same?
This is a
manifold?
separate system.
Okay. All right, thanks.
Yep, this is a separate system from the failure that occurred. Yeah, I should also add that, yeah, we have redundancy, and in the spin system in particular, that we have our primary mission, which is obviously to deliver Dragon into its orbit. After we do that, we like to dispose of the second stage. So what we want to do is be able to relight the engine to dispose of the second stage and get it out of orbit as soon as possible. So that is the goal of this, and that's mostly what we're looking into. That part of the mission could be impacted by this leak, and we're just checking it out further.
Are you orbiting the stage a requirement now?
It is a requirement for certain contracts and certain vehicles. I do not believe it is a requirement under the CRS contract, but we choose to do it, so.
All right, further questions? Let's go right in the back here.
Hi, Stephen Clark from Spaceflight Now. I have a question for Jessica. I think last year, we heard that SpaceX was thinking about reusing a Dragon cargo vehicle for a CRS mission, and I think SpaceX CRS-11 was the number, and that's coming up next later this year or the spring. Has that been finalized by both NASA and SpaceX? Maybe Dan can chime in since he has a role in that too. Thanks.
Dan, do you want to answer that?
All right, well, I'll be glad to take it. So our plan is, again, for CRS-11, it's going to be the Dragon. Is that so? Not the Falcon, not a reused booster. Yeah, exactly. So that is we've done a lot of work with SpaceX over the last year and a half or two, looking at Delta verification requirements that we need to be comfortable to satisfy ourselves that Dragon can approach the ISS, get within the ellipsoid, be done safely. And so a lot of technical work has happened, and I would tell you everything is leaning good. That the next Dragon mission that we'll launch will be a reuse. As far as the booster, we've just, I'll say, started those discussions. We've got some teams off generating how we'll even go about at requesting information from SpaceX, kind of laying out our plan. I imagine we'll have some sort of preliminary review on that, I'll say in the April-May time period. But I think planning-wise, it may not happen this year, but shortly thereafter.
All right, questions on this side of the room? Right here.
Jim Siegel, I'm with Celebration News and Spaceflight Insider. I have a couple questions about the payload, the medically related payload that are on this flight. You mentioned a couple of experiments that have to do with directly or indirectly osteoporosis and antibiotics. And I was interested if you could elaborate a little bit more on each one of those. How do those experiments relate to a benefit that we'll see back here on Earth, and about how long is that going to be? 5 years, 10 years from now, or what?
Oh, such a good and loaded question. I love it. So the thing about spaceflight is that we see lots of different changes from all the way from the cellular level to the human physiological system. And so this particular flight and this particular set of research, we're focusing in on immunity, stem cells, and wound healing. And so the first one regarding immunity is investigation of an already FDA-approved drug from Merck. It's called Keytruda. And this is a drug that works with the immune system to basically fight disease such as cancers, some cancers. What they want to do, what Merck's using the microgravity environment to do, is to try to grow this type of medicine up in a crystal form so that it is more effective when given in injections format, because right now that drug is given intravenously. So the researchers will get those crystals home and look into those crystals and see if there's any insight that they can use to help improve their FDA-approved drug already in use. The second is an investigation on stem cell growth in space by the Mayo Clinic. They have a goal of trying to mass produce stem cells that can later become any kind of cell in the body that you desire, and that could be very powerful when treating diseases. And so they hypothesize that the microgravity environment could help produce larger or faster numbers based on the investigations they've seen and the results in the past from use in space. We have done stem cell research in the past, and it looks like this could be promising. Another is from the Department of Defense. That's the wound healing investigation. That will be looking at the healing of wounds in our mouse population that we're sending up on this flight. That will be, we've seen some of the wound healing processes slow in space. And so what that has to do with, no one's quite sure. It could be immunity. It could be environment. But so we're going to look into this a little bit more and try to get some answers back on that. And these kinds of things, I mean, you know, the immune system's a big one, all these investigations. And when we think about things like osteoporosis, then we think about the fact that our crew members on orbit, if they didn't have their exercise routines in place, they could lose bone at a rate of 1% to 2% per month, which is more than even a postmenopausal woman. And we can use our crew members as models to try to understand in an accelerated way what's happening with bone loss when you don't use your bones. And so we look at that as parallels to osteoporosis, since you mentioned that one. Thank you. You're welcome.
Yes, question in the back here.
Bart Leahy, Spaceflight Insider. Question is for SpaceX. Why are you landing on land this time versus landing on the barge?
Whenever we can land on land, we would like to land on land. It makes it a lot easier. After we land the first stage on land, it actually comes over to 39A for processing, and it's just a much simpler and less expensive operation than having to send a drone ship out, land it out there, and transport it all the way back. So whenever possible, we want to land it on land here.
All right, let's take a question from James Dean, and then we'll go for social media. James?
Thanks so much, James Dean, Florida Today. Jessica, I wonder if you could just recap as simply as possible what the issue was in September and what you've done to get back to flight to correct that. And then Dan as well, I just wonder if you could comment on the separate investigation that NASA did, and did it learn anything different or anything else helpful, or were you all kind of on the same page? Thanks.
Yes, so I'll start. So in September at Pad 40, for one of our commercial spacecraft missions, we were fueling for a static fire, and we had an explosion in the second stage tank that then took out the rest of the vehicle and the satellite. So what we found that to be was a rupture in our helium system. And as we looked a lot closer into it, we did one of the first things we do actually is form an accident investigation team. And on that team, we have NASA, the FAA, the Air Force, tons of our partners on that team, as well as several SpaceX experts. And we form a fault tree analysis to go through and look at every possible thing that could have caused this failure to happen. And we try and address every single one of those. Any one of them that comes up credible, we have to address corrective actions against it. And so we have a very long list of those, very long list of faults. Some of them wound up not being credible. And then anything that could have, even if it likely wasn't the actual cause, we still try and implement corrective actions against that. And so some of the things we've done is change the way we load helium into the rocket. That's been one of our main corrective actions, as well as going back and looking at our processes to make sure that a failure like this couldn't happen again.
And we had an independent team working right with the SpaceX team. It was actually led by our LSP program here. They did a very similar exercise, fault tree analysis, and then we look for basic root causes as well. And I will tell you, learning about submerged in very cold temperatures, the COPV. Even our NASA expertise, right? That's a little bit out of, I'll say, our boundary conditions as well. So we're actually going to go, with SpaceX, go do a lot of testing and really try to understand that for future use as well. How a COPV in the conditions that they're operating in perform, how we think they should perform. You always get into this test like you fly kind of thing, and so that kind of philosophy got brought across several systems, and Jessica mentioned it. There were corrective actions that they found as they applied the knowledge that they learned from this investigation. They applied it across other systems, and there's some things that we'll probably that they agree that we need to go work on as well, and so those will all be put into motion to again. Learn when you can. It's Gerst always says some of these anomalies are a blessing that you get to learn from them. So we're trying to take maximum advantage of that.
Okay, let's do a social media question here.
Sure. I'm Emily from NASA Social Media, and I have two questions from Twitter. The first one is, was Dragon mounted during the static fire test earlier this week? If not, is this a new precedence for static fire tests?
So no, it was not. Sunday, we went out for static fire, and it was just the rocket by itself with a cap on top. For now, that is how we're going to operate. We are going to continue to perform static fires without a payload or without Dragon on top. But we do believe we can get back into safe operations. We do believe that the way we're operating now is safe, but just out of an abundance of caution, we are not going to have payloads installed for the near-term future during static fires.
Second question, students created parts that are on the payload as part of the Hunch program. What are other ways that students can participate in future launches?
Oh, I love that. So students participate in just about every investigation that goes to ISS. I mean, seriously, whether they're undergrads, graduates, or K through 12, there's always some element of education. But there's also things like the Sally Ride EarthCam project, where students can sign up, get on their computers, pick a target of interest that they're interested in the space station taking a photo of the Earth, and get those photos sent back to them. There's also projects like the ISS ham radio, where students can get together in their schools and communicate with the space station, with the astronauts on space station through ham radio. There are investigations through our partnership, our international partnership. Sometimes it's like sending up seeds, like tomato seeds that are going to be sent up on this flight by our Canadian Space Agency partners. And you get those home, and students can grow those up and create a curriculum to see what comes out of that. So there are all kinds of different educational components, and also lots enabled through the National Lab payload. Things like that go inside of the nanoracks and the Space Tango hardware, where there's fully data and there's imagery, and some of these samples can get returned as well. I'm seeing things like fruit flies for students who are studying and trying to correlate to Parkinson's disease. Or this time we've got how a cactus scrubs carbon dioxide out of the air, and there's an actual carbon dioxide sensor with some cacti growing in there. So these students get really creative, and it's just becoming more accessible for them to get their investigations on station, and it's great. Because when you're a student or you're a kid like me who loves space, this kind of opportunity would have been a life changer. So it's real exciting.
That Hunch program is just really cool. I mean, these students across the nation, right, working with their teachers, and their teachers work with some of our design engineers, and they are actually designing, building, flying, things that we really use on the International Space Station. It could be simple things, they're getting more complex. And then, we get to go share, even with the crew members, they share the experiences of how their hardware that they design and build operated on orbit. And so it's just one of our better programs we have here at NASA, quite honestly. It's awesome.
You see managers light up all the time when they talk about hunch. See that?
Yeah.
All right, Bill Harwood from CBS, a follow-up.
Yeah, just a quick one for Jessica again. I just want to make sure I understand. You said this was a redundant system, so I assume by that it means if the second system didn't work at all, your second stage would light fine going uphill and it would light fine to deorbit. Or are you saying that the issue is you could light fine going uphill, or you might not have the pressure to deorbit? Which scenario is accurate?
It's the latter. That's what you're saying. But, with any, whenever you have any issue on a rocket, you really want to ensure that just because you think it's going to affect the secondary goal, you really want to make sure it's not going to affect the primary mission. And so we're still doing our due diligence today to ensure that this will, we will have a low risk mission and that this will not impact the primary mission. So, we are really thinking it would affect the disposal burn, but we want to make sure that it will not impact the second stage burn tomorrow.
Okay, thanks. And one more, and maybe this is for Dan or either one of you. I've never really understood how you think the helium tank ruptured. I mean, what physically caused it to rupture? What was the physics going on that made the COPV burst? That's what I'm not making a connection between, you got the high pressure helium going in an extremely cold environment. You had some buckles in the carbon fiber overwrap, but I don't understand the heat source or what could lead to a situation that would make that tank rupture. I've never understood that.
So we've looked at different credible causes, and I can't go into too much detail about them, but we have found credible causes that would cause an ignition event around that area. So that's about all I can say. I'm sorry.
So oxygen trapped, I'll say, in some voids, and then things like friction can be an ignition, right? So you can, around buckling. So there's scenarios. That's one scenario. And again, part of this is they've changed operating procedures of how they're actually going to go load. So from our comfort level, we're there. Where they want to go, we understand. And so that's why I think we can join forces with them in looking at how we can do some additional testing with these kind of tanks at very low submersed temperatures.
All right, well, we have no questions on the phone, and with no other questions here in the room, just a short programming note that we have another question? Where? Oh, goodness, all right. Well, we won't stop. We got a little bit more time, so we'll take them. Ken, right here in the front.
Hi, Ken Kramer, Universe Today Northeast Astronomy Forum. For Jessica, you're the Dragon mission manager, so I would like to ask you about reusing these Dragons that now you want to use on the next mission. Yep. Tell us about the work you need to do to enable that, as well as Gwen Shotwell mentioned that you're going to reuse one of these, she just mentioned this, to send to Mars. So how are you going to do that? What are you going to select? And the other thing I'm wondering is about the late load cargo. 1,000 pounds is about 20%. And so how are you able to do that?
Yeah. So we'll start with the reused Dragons. The process is it's twofold. So first of all, you have to ensure that every single component on Dragon and all the structures are qualified for multiple flights. And this is not atypical. That's what shuttle had to do. Aircraft have to do that. So you just have to ensure that all your components are thoroughly tested and analyzed for all the flight and ground cycles that it will see. So that's the first step. And then the second step is to have a thorough refurbishment plan. So we have to look at each component, look at areas, obviously Dragon splashes down in the water, so we have to look at areas that could be susceptible to corrosion, and we have to have very thorough inspection procedures. And in certain areas, if inspection is going to fail, we have to make sure we have hardware ready to replace it. So while this capsule is mostly a reused capsule, there are definitely components that we looked at and we said, hey, it's actually going to be smarter to use a new component in this area. And we've provided all of this data to NASA literally on a component by component basis. And actually they've been great with their experience on shuttle. They've reviewed every single one of our qualification plans as well as our refurbishment plans for every single component and have provided us feedback that's been very helpful. And I forget, what was your second question?
How are you going to select the
So it's actually going to be the same approach. Now, instead of seeing the same mission twice, it's going to have to see a very different environment. So, but again, the same philosophies apply. And the late load cargo is a lot of practice. So we've actually been doing this since CRS-1. We had a little bit less late load cargo. We actually increased the vehicle starting on CRS-3. So starting on CRS-3, we significantly increased the capability of late load cargo on Dragon. And what we did is we knew we could physically, you can run time studies to physically show that you can get all the cargo in that amount of time. And then we practiced it. And so we practiced it several times before we actually had to do it. Because, once you start, your mission's coming up in 24 hours, so you better get it done. But our teams have now done it. We got it down, and it's no problem.
We're pushing it, right? So, the more we can get into late load, those scientists really appreciate something being loaded at the 24-hour, 36-hour time period. So we have constantly been requesting how can we actually get more stuffed in that late load, very late load access point. That's where you see our glaciers, our freezers, all kinds of freezers going in with all those samples. We bring those out from the SSPF, and we have fine-tuned this, and we're working with the Dragon folks on how they actually do that and integrate that. In fact, we both witnessed it out there this morning when they were loading in the glaciers, and they had the animals or the animal habitats ready to go, and so. They've done a remarkable job, and we use it. Our life sciences research community really appreciates the amount of research that we can get and the timing that we're able to load their samples in and then get those returned. It's been awesome.
Do you have a question right behind Ken? Did you have one? No.
Hi, I'm Sarah Lewin from space.com. My question was partially answered just then, but I was curious to some examples. I'd imagine the mice and their habitats of the time-critical science payloads that are made possible by this late load.
That's a good question. So from what I understand from talking with the scientists this morning who have been up all night, that would include the stem cells, possibly the protein crystals that are growing as well. That's going to be grown as well. And the bacteria that we are sending to space station that have to be late load, last minute critical. And again, those teams have been up all night, and as Dan said, he watched them get loaded this morning, and those teams are exhausted and excited.
Okay, we'll take one final question. Stephen Clark, I think you had a question. Here in the back.
Stephen Clark, Spaceflight Now again. Hopefully a simple question for Jessica. Which pressure shell will you be reusing coming up on CRS-11?
It's the CRS-4 vehicle.
All right, with that, we'll wrap up just your programming for tomorrow. We'll start with the launch broadcast on NASA television at 8:30 Eastern Time. And then after launch, there will be a post-launch news conference here in this room at 12 noon. Thank you very much.